So what I really want to talk about is how you can use the ENTREZ browser in NCBI to pull out subsets of data which can then be used in marker discovery. Okay. And so again, what I would encourage you to do is go back to the NCBI website in your own time and look at the information that they have on advanced searching, because it's a fairly detailed description of the sort of commands that you can put into the search box that will help you retrieve more specific information. So one of the things that we're faced with as sequencing becomes less costly and more efficient, there's a lot more information out there. And so we have to be better at sorting through it to get what we want. Okay. So the ENTREZ browser uses Boolean operators, and, or not, all capitalized. Okay, those are key commands that can help you search. They also use search field qualifiers. Okay, and learning some of these search field qualifiers can also help refine what you're doing. And so what I want to do is provide you some specific examples of that. And so what I'm demonstrating in this particular page, what I'm emphasizing is that first of all, we can select the database that we're going to search, right? So we can search either the nucleotide database, EST database, GSS, etc. Okay, so the information that you start with is going to be important for what you get out. Okay, so in this slide, what I'm emphasizing is that here I've selected the EST database. You can see here where I'm putting the cursor, and then what I've done is I've typed in lycopersicon, and I'm using a field qualifier for organism. Okay, I'm using the Boolean operator and then it's kind of scrolled out of the box here, but I've typed in the name of a variety, in this case Rio Grande. Right. And so what happens now is when I hit that search, what the database returns to me is 21,973 sequences that are Solanum lycopersicon from the variety Rio Grande. Okay, so what I've done is I've used the Boolean operators in the field keys to create a set of data that are all the ESTs for a single variety. Okay. What I can do now is I can take that and I can send it to either a text file. I can essentially save it. Okay, and what I save now becomes important. Okay, so again, in this case, what I'm demonstrating is that I can just save the file. And in this case, well, it's going to give me the choice of either opening it directly or saving it. And I would recommend that you save these and not try to open them directly, because it's very easy to get data sets that are too large to actually open in most of your text editors or word processors. Okay. The other thing that I want to point out is in this case what I've selected here is summary. All right, it's unlikely that that's actually what we would want to download. What we're probably going to want to download is the FASTA sequences. So I've selected that here and then saved it, and what I get is a set of sequences that fits my Boolean search string. And so in this example, I'm giving you another Boolean search string. In this case, it's for Phytophthora as the organism. I'm using Howard Judelson as an authority. And over here, I also add tomato. Okay? So the reason for doing this is that this set of ESTs, which is housed in the database, comes from a tomato variety, Ohio 8245, that's infected by Phytophthora. And so it's an interaction library, and it's annotated under organism as Phytophthora, but there's a little note that says it might be of plant origin. And so my thinking is that a large number of the ESTs in this set of 3,921 could actually be from tomato, and not only that, from a variety that's out of the Ohio breeding program, and so the sequence might actually be useful to me. Okay. And so what I'm demonstrating in this slide is just a number of the variety-specific sets of data that can be downloaded. And what I want to highlight is that TA496 has over 116,000 ESTs. Microtom, which was developed by Jay Scott right here at the University of Florida, has 120,000 ESTs available. So once we separate out the data this way, it gives us a way that we can then do some marker discovery simply by comparing one to the other. Again, keeping in mind what I said about the need for redundancy because of sequence error in the EST databases.